CEO of Agronova. Thank you, gentlemen, for being here. Sorry again for the late starting. So the first question that I asked to Cédric was the following: with the current regulatory framework, are we allowed to operate autonomous machines in the field without any local supervision? And his answer is yes, but it is not actually described, and manufacturers have to do their own risk assessment and own development. The risk is to have differences of appraisal arise in the sky level and the mitigation measures used between both machines doing the same job. The user can be at a loss at the present time to understand behind commercial speech what is at stake, who is liable in case of accident, what are the responsibilities of manufacturers, dealers, users. Jérôme, you want to add something? Gérald, you want to add something to this?
Yes, maybe I start by quickly introducing myself. So I'm the director. You hear me there? Yeah, okay. I'm the director of a European association of what we call in English contractors, in Netherlands loonwerkers, en français les entrepreneurs agricoles. So we are an association of about 20 countries, the biggest ones being Germany, Netherlands, and France. And we have a Belgium association called Agroservice, Landbouwrobots. I know they made a breakfast on Wednesday here, so maybe some of you attended. And we are, of course, as contractors, we are at the first place to use precision agriculture and smart farming in general. So, of course, it includes robotics. And we do have a lot of debate and discussion with people, the manufacturers of all these devices, actually. And I would say, yes, for us, it's very important to have this machinery, not only because they are efficient, but also because we have, as other sectors, a problem of shortage of workforce. We don't have enough people who want to work in our sector. And having machinery to help us on this is of course, something very important. So now to answer a bit more what Cédric said about safety and use of machinery, I would say that we always need control. We need control not only because we as entrepreneurs, we have to report to the farmer. The farmer is our main client. He asks for something or she asks for something, and we have to deliver. So it means we have, when we do, for example, spraying, we have to say, okay, we did this and that and there. How many products did we use? Which product did we use? Etc. etc. This is very important. Of course, there are always trouble. Like every machine, like your mobile phone, sometimes it's not working. We need people to be there to monitor. We need to be able to have the help of assistance when necessary. So all of this is of course very important. And maybe the third point I would like to add, which is not in Cédric's point, but it's very important for us, is safety against robbery, against theft. We see more and more at the moment in Europe a problem of GPS being stolen. And we think it's something organized because we have people all over Europe, in France, in Netherlands. It started in the Netherlands, but it's now everywhere. They see 20, 30 GPS stolen in one night, and we find them in Russia or anywhere. I mean, it's a big issue. And we want to work with the machinery industry, with SEMA in particular, to see how we can more secure the machinery. Because now it's GPS, but it can be later other type of connected devices, and there will be more and more connected devices. So it's something we really have to pay attention to. I think I stop here now. Thank you.
So just to go on with the questions that I addressed to Cédric, the second question was, a new machinery regulation is going to come into effect in 2027. What's new with it? And he answered, for me, it merges with the next question, what are the new requirements? We'll come to that question. Main topic is autonomous machineries are defined, supervision is defined, limited order and command can be done remotely, framed for safety function based on IA. Anything you want to add to that?
Well, I hope it will be the case. But we don't build machines, so it's not our first responsibility. Maybe to have an additional point on that, because all he says is totally correct. There has to be a differentiation between a machine used for work and the machine used on the road. Because anyway, you need to move the machine at some point. Huh? And on this, the requirements are something not very clear at European level. For example, road circulation are still national competence. So in some countries, it's very strict. In some countries, it's not. And we work with people from SEMA on what we call the type approval of machine, meaning that once a machine is authorized EU-wide, then it has to be fine-tuned at national level to make sure that it can drive on the roads. So it's not a question of agriculture work, it's a question of circulation. And on this, we think that we could be a bit more, I'll say, harmonized at European level. It's a bit a mess for the moment.
Let's get back to the... Do you want to add something on that, Gérald? Yes, absolutely.
Yeah. Hello, everyone. I'm Gérald Tonglet, the CEO of Agronova. We are a company, Belgium company, specialized in technology, and we are working with Nayo Technology, so I'm a robotics producer since 2015. And to speak a little bit about IA in robotics, especially the vision of Nayo Technology, we think that autonomy, it's also a question of security. And the day that IA will come into robotics, we will need to have some barriers, to have some fencing, to be sure that IA won't dysfunction. So we will need to certificate IA, and nowadays it's not the case yet. I hope that it will come a day, and this day we will be agreed to accept IA in our safety system.
Yes. So what is the role of a constructor in that development, in that matter?
In the vision, I won't speak for others, robot producer, but in the vision of Nayo Technology, we would like to become we would like that Europe become the Silicon Valley of robotic in the world. So we have a mission. We think that we have a mission that we need to be at the first point of the evolution of the technology, and to drive the change of the being. So the idea of Nayo is to try to stay at the first point, to create and to innovate every day, to stay and to be the first one.
Let's get back to the beginning of our conversation with you, Jérôme, because you said you represent on the European scale agricultural entrepreneurs who rent machines to farmers in the 22 countries of Europe. Could you tell us what is the state of art in Belgium, in Europe, on that matter, maybe?
Well, I think we talk about a very concrete example is weeding robots. So today we talk a lot everywhere about pesticides, plant protection products. There was a big discussion on prolongation of glyphosate in Europe. First of all, entrepreneurs today have the devices, have the technology, have the skills to limit the quantity of plant protection products sprayed. They are solutions. They already exist. But on top of this, weeding robots, maybe if we use them well and if we develop them, would totally allow to get rid of much more of pesticides. So for me, it's a very good example of what we can do in the near future. It's not science fiction. Huh? It's the near future.
Yeah, I am totally agree with you. I didn't say it, but I'm a CEO of Agronova, but I am also a farmer in Belgium. And for me, the robots will be a solution for limiting the glyphosate, for example. Because the robot won't work like glyphosate at once a year or twice a year, but they will work every day, every week, a little bit, with a little impact on the soil, on the vegetables, and that will allow us to do not work anymore with the glyphosate. Robots will make that difference and to authorize the automatization of weeding.
Jérôme, you touched to a very important point. Actually, you both touched to safety. Safety is essential. Safety is key. How do you control it?
Well, I would say we think that today, if you take a mobile phone, you can trace it everywhere in the world. If you take a GPS, we don't know how or why, but it's impossible, or it's not on the market at the moment. And we have serious discussion at the moment with SEMA. We have a meeting with our board in 2 weeks, actually, that I'm now preparing, specifically on this, to say, is it a possibility, for example, to link the use of a device to, how do you call it, your digital print, it's like you do on a mobile phone. So it means that not anybody could use it. I think that's a good example of something we could do.
Safety, it's the big issues for the robotic world for me, because we have one chance to convince the farmer that it can be a part of the solution for within 10 years, and from that we have to give them the certainty that it works in any case, like the tractors are doing it today. So for that, especially also for NIO, but I see also for my partners, safety is the first point that we have to be sure on it. At this point, the farmer will be more allowed to use it every day. And the difficulty is that the law, as we already spoke, is there. We can work with a robot on the field, but the interpretation of the law is not that much easy.
And in fact, so on that issue, what could be the different solution to maybe answer a lack of legislation today?
The good answer for that is innovating, and I think see what's on the field, testing it, have hours of work, and from that make our own legislation. And I think that the robots builder don't have to be the only. We don't have to be judge and third party. We need to implement other vision, external expert that can say, okay, robots are safe, and it's the case today.
Jérôme, can you give us a word on what's new on legislation? You talked about safety on the road, for example. What's new on that?
Well, I would say this point is very important, but it's also, as I say, differentiate between what we call road circulation and the rest. Road circulation, we have the feeling that the agriculture world is still seen as a bad guy on the road. It's still a troublemaker. There is big discussion, for example, on big pneumatics. We are hampering soil. We think that it's not always the case, because the bigger the machine, the less you need to move it, because you can only do once. So I think on this it's important. Maybe one point I would like to add on this, where we are preoccupied, is alternative fuel, meaning that you see that now cars are becoming more and more electric. Machinery can become electric to some extent, because it's not always possible. But we have the feeling that if you target the sectors, agriculture is a bit set aside as compared to other sectors like, I don't know, maritime, aviation, etc. We have a limitation of the use of biofuel at European level. For us, it's preoccupying. I think we should develop biofuel. Why? Because it can happen that all the biofuel goes to other sectors and not for the agriculture sector. And that's a problem for us.
Gérald, what do you think of that? Is the energy an issue today for you as a farmer? Are you thinking electric? Are you thinking alternative solutions?
As a farmer, yes. When I see that, for example, it's €2 a liter and we have to go deeper into the soil, that consume more energy, more gasoline, there is an issue. And I totally agree with you. I don't think that agriculture will be the first that they will deliver. So robotics and technologies can also be an answer for that. We have some studies that a robot can cost maximum €500 a year of electricity. So that can be also a solution on this point.
But that's a budget.
€500 a year,
Yeah?
for 220 days of work.
Okay.
That's not that much.
Okay.
Sometimes it's €500 an hour or 2 hours if we have tractors and machines. So
So tell us maybe, Gérald, what does NIO do to set up today in terms of safety towards complete autonomy?
Yeah, as you know, Nayo Technology have sent during the Agritechnica, we have sent the first robot that's 100% autonomous, without any human supervision, and that's possible because we have, I would say, 4 things. The first thing is that security is not linked to the robot. It's 2 different parts in our system, and the security always have the priority on the robots. So that's the first one. Number 2, we have 3 ways of security. First of all, physical security, that we have bumpers. If you touch it, the robot stops. In security, what's at the rear is that it's the problem, the main issue is that it's the speed and the weight. For that, and to be sure that we are safe, we need that the robot do not go at a big speed into contact with someone or something. So for that, we have the second level of security, which is a LiDAR, like in the army. In fact, it's the same. When you enter this digital world, the robot will decrease its speed. That's the second security, and stop. And the third level of security is that we have a digital. It's geofencing. It's a digital world on the field that the robot cannot get out of it. So that's our 3 level of security. And the last one, Nayo Technology also do an audit of the field to be sure that everything is okay for that. And those 4 things allow us to say that our robot are 100% autonomous.
Yes, I would like to add something on this about something which can be a help and a hindrance, which is data. Because data can be of a good help for safety, for recording, for many things. But we are a bit afraid that monitoring everything the driver is doing may hamper may create an artificial stress toward the driver, who would feel not comfortable, would be afraid to, and in a world where we have more and more people to recruit motivated people to do the job, we have to give them confidence. We have to give them the skills, we have to train them, it's very important, but we also have to make sure that, okay, everybody makes mistakes, and that's something we have to pay attention to. So in a world where everything will be more and more digital, it's important to keep the human side in the story.
Well, in fact, Gérald, I want to ask you the question. So as a farmer, do you think that data collection can create some stress? What's your approach on that?
It do not create stress, but we are at a period where we have to learn new things. I always give the example that my grandfather still has horses, my father have tractor, and I'm coming with robots. And we have a change of way of living, of way of working, and that we have to teach to the farmers. And data can help that. And as what I see in Belgium, because I have some robots that are working, I think that nowadays robots can be, we can have a return on investment with robots, especially if we count the workforce in the calcul. But the last step is the mindset of the agriculture, the farmer, that need to say, okay, I go on the train, I go to this world, and I need to change my way of working to adapt myself to the robot. That's not that yet. We are not that yet ready.
Does it mean that as a farmer today, you cannot work without robotics, without data, or can you still?
You can. You can. That's a good question. You can. As I can see on the fair today, there is more and more data. There are more and more robots. And nowadays, I think that the agriculture will be obliged to be more efficient, and data will help us to that. It's finished to work. Okay, it's not a problem if I put 10% more, 20% more. That's finished. We will need to be efficient and to look to our production, and data will help us to do that in a world in in a job in which we still work with livestock, with vegetables, and so.
One last question. Well, go ahead, and then I have one last question.
Yes, just I wanted to add a compliment. I totally agree with what he says, but I think we have to think also about circularity nowadays. And I think it is important to have also two types of device, because a tractor has a long-lasting life as compared to a device. A device is old after 2-3 years. There's something new on the market. A tractor, you can last it maybe 10 years. I don't know. It depends on the machine. So we also have to think about be able to adapt the device to traditional things. So I don't think we should oppose the traditional way of working to the new way of working. The two should go together.
The last question I wanted to ask you both is: do you have the feeling that you're living through a very challenging and exciting era?
Totally. Personally, I come from a startups world. I worked 10 years with startups in many different topics, especially in the medical area. And I started to work on this topic in 2018. And when I joined the association, I said to everyone, I don't know anything about agriculture. I say, it doesn't matter. You know something about artificial intelligence, you know something about device. That's our future. And for me, it's really the new frontier. It's definitely the new frontier.
Gerald, do you have the feeling to be in the middle of a very exciting and challenging time right now?
In the middle, not. In the beginning, yes, because we are doing robotics since 2015, and between 2015 and 2020, it was not that easy. It was really difficult. We were alone into the desert. Since coronavirus problems, there is lots of problems with that. I agree, but that makes the switch in the mindset of people, especially in my generation of farmer. And nowadays we are ready to switch. We understood in our body that we need to move on and to change our way of living, working, and so. So we are only now, for me, entering the era of robotic and new vision.
Thank you very much. Both of you, do you have one last
Thank
message,
you.
or are you good? Are there any questions in the audience? Any questions? No? Well, thank you so much, gentlemen, for participating.
Thank you.
Into that session, and Gerald will meet you for a pitch session in a couple minutes.
Exactly.
Thank you so much. Thank you very much. So let's start our pitch session while the audience is warm, let's say. With Gerald, I'll let you introduce your company. Thank you.
Yeah. Hello, everybody. So, as I said, I'm the CEO of Agronova. We are a Belgian company based in just next to Namur and specialized since 2015 in the robotics with our partner Nio Technologies. We have 3 robots that are working in Belgium, 2 little ones and one big one, which is the Oreo, which is on the stand Agronova over there. And we try since 2015 to develop, to change the mindset of people, to show that robots can work. We also that it's also efficient, and I think that since 2 years is it now. So and as I said, as a farmer, I have also the faith that robot will be the solution against chemical products, because with robots we will be able to work with several robots at a little speed, and this little speed will allow us to go more close to the plants, more close to the vegetables, and that will be the solution against chemical products. And as I said, I think that robots are also the solution to augment, to increase the bio production in vegetables. So yeah, that's we are doing, and perhaps that we have presented. Do we have the video of the robots working? Of no. Oreo, the robot Oreo from Agronova. Yes. So yeah, to give you a more practical vision, that's the Oreo from Nio Technology, which is on our stand. And the idea is that the robot is a tool carrier. We have 4 wheels. Okay, we place the tool between the 4 wheels of the robot. That's for us the best place to be 100% precise with the tool. As you can see, every reel turn at 360 degrees to the second line. The robots are made to be on the digital map that you have to make, to create before, and the robot will, all the white part will follow this digital map, and in the robots the tool will be more precise with a Teletenag camera, for example, to go as precise as we can. And that what I said exactly, that in the last picture we saw 2 robots in the same field. I think that will be the next level, when a farmer will have 1 robot working, and that they will be not stressed anymore, and that they will be agree with that, and that they will have the habit to work with robots. They will go to 2, 3, 4 robots on a field. So that's the way we are working.
Thank you very much.
Thank you to you.
Bravo. Yeah, bravo. Woohoo. Let's move to the next.
So thank you, Sophie. So I will tell you a little bit about robotic and what we can do for the farming today. So robotic is an autonomous tool carrier. We can carry different types of implements, and we can do different types of tasks on the field, such as seeding, harrowing, weeding, spraying, or even doing some soil preparation, enriching, and so on. As you can see, we can work with the highest precision, so we are made for precise tasks on the field. For example, in-row weeding, you can do much better with a robotic than with a standard tractor, because the position of the cameras is in the right position. And also we can work with the highest efficiency. We can work 24/7, we can work at night, we can work when the farmers should sleep. And therefore also, like, you know, I mean, even though we are smaller machines than sometimes the tractors or what the farmers are used to today, we can also carry the tasks for a longer time or in a low speed, and also during the night, so therefore higher efficiency. We are based on a diesel and standard hydraulic. Therefore, we are working reliable on the field, and we also are using standard components which are very well known for the farmers already. What is important for us is safety. I mean, it's just safety first. So we are based on the sensors which are in the front, cameras, and also sensitive bumper around the robotic. We have protected the implement, as you can see, which is placed in the middle of the robotic. So therefore, you can leave the machine on the field. There was now the discussion about the legislation. So we also follow, as a manufacturer, all the legislations which are now in the EU and also in other countries. So therefore, we say that you can leave the robotic autonomous working on the field without human supervision. Of course, like, you know, I mean, now the current legislation, it says that it works fully autonomous, but you need just someone who is then kind of logged in our system and who is actually the operator. But it does not have to be on the field. Here you can see some of the operations, some of the examples I have already mentioned. So like seeding, or on the bottom picture you can see doing the ridges on the field, or some simple soil preparation. And we work with many implement manufacturers from the industry, such as Monosem or Kult, which you can also see on our stand for the in-row weeder, Stenhay, Konskilde, and so on. Here it's a little bit more about the safety. I mean, what is also important to say that robotic, when it's in autonomous mode, it only moves forwards and it only operates in so-called virtual fencing, which means that it only operates in the area which we have prepared before. And it also monitors the obstacles with LiDAR scanner, which is in the front with the cameras, and also with the online remote stops. Here are some technical specifications and also the crops we work with. As you can see, we work with a lot of horticulture crops, but also we work on arable crops or row crops. So robotic is really a universal machine where it's very flexible, so you can use it for different types of tasks and also for different types of crops. We can carry implements up to 1,250 kilos. So therefore you can also put some heavier implements on the robotic. And with our fuel tank, which is now 300 liters, we can actually work up to 60 hours on the field. Here the position of the cameras. So we have a front eye camera, the rear eye camera. The front eye is watching the front, what's happening in front of the robotic. The rear eye is watching the implement, or it can be placed also behind the implement, so it monitors what kind of work the implement have done. And then the crop eye camera, it's on the bottom, and it's based on our vision system. So it's actually watching the soil, and also it can monitor the weeds. We also have a special function now in our planning system, so that you can say with the crop eye camera, you monitor what kind of weeds you have on the field. And then you decide, okay, in the first weeding, we are weeding the complete area, the complete field. But in the second weeding, we can see that in a corner of our field, there are a little bit more weeds. So we are then just weeding the subfields. Then all the information is transferred to the cloud server, and then you can see how it looks on our web platform. And here's some more images, how it works in the system, in our web-based platform. And if you want to see it in real time, we have it on the stand. So please come and we'll do a demonstration how the robotic can be planned and what kind of operations it can do. So this was all from me in 5 minutes. Thank you so much for listening. And then I will give the microphone and
Jonathan, if you want. Thank you, Anna. Jonathan, you want?
Well, Jonathan also has some pictures of robotic and some videos, so it's a good combination.
Kult. Thank you very much, Anna, for
Thank
this
you.
very relevant presentation. And now we move to Jonathan Scheffer for Kult. Just the time we find the presentation and you're ready to rock and roll.
All right. Okay, maybe I can start to introduce myself. My name is Jonathan. I'm responsible at Kult for robotic in-row weeding and also for Belgium, Netherlands and Germany mainly in special crops. So we just wait that we see something. Okay. Kult is coming from 30 years of experience in weeding technology. For example, the finger weeders, the plastic fingers you see on different kind of weeders, also on that fair. They are our patent. They are coming mostly from us. And well, we are coming from vegetable production. We started really early with in-row weeding in all different kinds. And well, since 6 to 7 years, we started to implement tools into robots. In all different kind of robots we have on the market right now. We will later see in my presentation, I hope. what we do for the robots. So we do developing, we are manufacturing the machines, like you see in the roboty over there. And we also consult every robot producer or every startup who is thinking about it to go into that business field, how to implement tools of all kinds. Okay. Okay. Yeah, and next time I kick off. I have funny stories a lot, yeah. Maybe we shouldn't talk about that now. Okay, so the main difference in reading is, do I have an inter-row navigation or I want to work in-row? Inter-row means I have a side shift in a robot, what's working really accurately. It means it's steering to the left and to the right. This is mainly necessary for seeded crops in a row. Here we go. There you see already the roboty from Agribex in front of our farm. And it's almost the same machine we're having here on this on the booth. So, like I said before, what we do for robotics, we are developer, manufacturer, distributors, and also consultant for robots, tools, and technology in all kind. This is just a quick overview about our main products. We only do weeders, hoes, however you want to call it. On the left top you see a hand-steered machine, like you maybe know it from the old timers. So that's the simplest way of navigation with the person. In the middle, on the top, you see a simple inter-row navigation system for vegetables mainly, for everything what's growing on the bed. And on the right top, you see the Culti-Select. It's a tractor-mounted machine. The same you see in the roboty over there. This is a hydraulic-propelled in-row weeder. There you see a different manual machine to drive in the front on the tractor. There's a big side shift, and what's getting more and more important is the multi-section machine. So we have one mainframe and 2 or 3 independent sections, each with a different, independent camera steering system. So these are some news represented at the Architecture in Hanover this year. We have a Cult AI laser, we have a Culti-Scan, and the e-actuator like you see it in our booth there. So it's an electric propelled in-row actuator for those robots without hydraulic. Yeah, it's like the Nio or Oreo over there. So we are one of the first brands to bring a laser reader on the market. It's called Cult AI laser. It sees with an AI algorithm the difference between a seeded carrot and a reed, and then shooting with a laser cannon the reed. Simple said like that. Yeah. So there you see the algorithm working. There's a triple row of carrots, and it can see because of the shape, the color, and the size what's a carrot and what's a reed. And it will shoot with a precision from 2 millimeter on the weeds, and you see it on the right side how it's looking after that. It's overheating the plant center, the protein is denaturating and it's dying after that. So this is actually a pretty big thing, would be also important for the Belgian market. It's an AI-based camera technology for seeded sugar beets. We have 1 camera per row, and it can see the difference between a 1 centimeter sugar beet and a reed. And it will steer the actuators, the hydraulic propelled actuators, around the seeded sugar beet and will kill all the weeds we're having. So we just start for next season to go with it into the cereal production. We're still looking for some farmers to start with us this kind of next step into the sugar beet production. So there you see the in-row actuator with the electric propelled version, like we showed before. There it's in our Oreo. We later see some video. There you see it in the front, in the whole perspective. This one was one of the first versions in California. And of course, on the right side, you see the robotic. Also with our side shift and in-row machine. Next is the farm to read. We also implement here new tools. That's a pretty fresh project right now. So I don't have videos or pictures from the field side. We just done it to replace the, let's say like this, the simple tool you see on the left side. And the next step is to implement our stronger and more experienced tools. So let's see some videos. This is actually a robot, what's not presented on the fair, I guess. It's a customer from us who bought a big machine and one of those small ones. It's actually a tractor-mounted Select, and it was so wet he couldn't go on the fields. So he took his X seat with the terra truck and just mounted the machine in the back, and he could work. Also in row, also totally independent and autonomous. You see my colleague has to zoom in because the sensors also of this robot will stop the machine immediately if a person comes too close to it. There you see the Nayo Oreo running there in California. They produce all the vegetables on ridges. And there you see the in-row actuators working. The camera is in front placed, like on the robotic. You see it over there. And here we have it. Right now, the most experienced robot we have on the market. Okay, you have seen a little bit, but it's the same video we have over there on the booth. Okay, we are back. No, we are not. But you can see the video on the booth of Agrointelli. Also, this robot is doing 60-hectare in-row weeding with our Select per day, independently. So this is the next step we do there. Thank you very much for your attention. If there are any questions, please ask.
Thank you so much, Jonathan, for this very interesting presentation. And of course, you're here on your booth if we have any question. Let's move and leave the floor to Nelson Segers for Exobotic.
Let me just, op de presentatie, we'll wait for presentation.
Yes,
first,
yes.
till it loads.
Exobotic, and then we'll have
I just was wondering.
Lemken, we'll have Ilvo, we'll have Eco Robotics with Sebastian Mosch to follow up. And yeah, very important, everybody's here on their booth, so if you have any question, do not hesitate to go see them. We're here all day. All right, Nelson, the floor is yours.
Thank you, Sophie. So I'm Nelson Segers. I'm business developer for Exobotic, and I'll start by quickly introducing what or who is Exobotic. So Exobotic is a Belgian development company. So we develop these new kind of technologies, mainly for agriculture. And we try to move these big data, artificial intelligence, these kind of buzzwords into a real solution that is easy to use, intuitive, and that's what we're doing. But before I go any further about explaining Exobotic, I'm actually a bit curious who is here. So I was actually wondering who here is an actual farmer. I'm even looking a bit further to see if anyone is participating, if there's any contractors, loonwerkers over here. Anyway, because I think farmers will definitely recognize some of the challenges that we have here. Some of these challenges that are widespread and that can potentially be solved with some of these newer, more exciting kind of buzzword technologies. But it can be quite easy, like labor, getting harder and harder to find people who are willing and who have the expertise to work on the farm, especially labor-intensive tasks. Autonomous vehicles can, of course, help with that. There's many over here. It's just one example. Another one is pests and disease control. What can we do against that? Except spraying is trying to predict as much as possible and to react in advance. So machine vision is actually a solution that can help by identifying certain zones that are affected by pests and to react more quickly before it's widespread. Another one, regulations, right? Limitations on pesticide, herbicide use. So that's definitely something that everyone is confronted with. An obvious solution, I know, but it's precision spraying. Just use exactly the right amount on exactly the right place, and it's possible to save. And I'm looking at eco-robotics as well, for the ARA up to 80 or 85% on pesticide use. And then the last one is expertise. That's also something increasingly difficult to have the people who have the expertise, a farmer who knows his crop inside and out, but there's getting less and less of them. So how can we counteract this? Is by putting something on a big data knowledge base. So what is it? It's just a big amount of data, information about your crop, and it's essentially the same as a farmer with many years of experience, thinking back about his experience and making decisions. So this is actually what big data can do and how it can help in replacing a bit this experience of a 60 or 70-year-old farmer. Now, to make it a bit more concrete, what does Agribex do? Because before it was quite general. One example is an application in tree nurseries, where currently trees, before they get sold, they need to be measured individually. It's a process that takes a lot of time, 10 to 15 seconds per tree, over sometimes 20,000, 30,000, 50,000 trees. So it takes enormous amounts of time. So we developed a camera, a stereo camera with an algorithm that can identify the tree, make a 3D model out of it, and take out the circumference of the trunk. So that's something that we can do in 1 second while we are passing by with a quad, for example. So it saves enormous amounts of labor. It's stuck, I think. Yeah, maybe just the next one, please. Yeah, perfect. So this is also something developed again for tree nurseries. It's an autonomous 4x4 robot, mainly used for experiments, but it's something that's 4-wheel drive, 4-wheel steering, and has incredible traction, which is needed in these kind of environments, often muddy, a lot of potholes. So that's something we developed to be able to, for example, do the camera measurements completely autonomously. Another one is in a plant nursery, so where we have a certain zone, you see it over here, in between the plants and then the road where the people drive. There's a zone with pebbles where all the irrigation hoses come out. Actually, they are now spraying it against herbs with glyphosate, and they want to switch to something that's more ecological. However, when switching to something more ecological, instead of spraying every month and a half, they will need to spray every week to have the same efficiency. So that's something manually it takes almost a day every week if they would need to be doing it manually. So they asked us to develop an autonomous robot, a bit of a smaller one, with an intelligent sprayer to be able to spray it autonomously within a week. And then the last one is actually a quite recent one. It's something I was surprised about, talking to a peas farmer who said that birds are actually still destroying such amounts of his crop while they are coming out of the ground, that it's something that might make him reconsider to actually farm peas still. So that's something we're looking at now, thinking about innovative solutions like drones, lasers that can actually be directed at the birds, even sound waves projected at the birds, and maybe just a little autonomous robot that's working like a Jack Russell, scaring away the birds. Now I would come back to the people listening, because I'm curious what you are here for. I imagine at the fair, many of you are coming for inspiration, right? To be inspired about all the new technologies. Some of you might actually have an idea already in mind or a problem that you are working to solve. I imagine many of you are also here for the free beers, right? But what I wanted to conclude with is that now, from Agribex, we can be here talking about new technologies, explaining what we can do, how interesting it is. But actually at a fair like this, I would like to propose the opposite. It's like get me away from my micro and start discussing. Because I can push technologies all I want, but it needs to solve real solutions for real farmers. So I need to know your problems. Let's discuss them, let's brainstorm about them, and see how and even if these new technologies can solve them. So I'd like to thank you for your attention. Feel free to come visit us at our booth, look at our robot in action, and I hope to see you and discuss about your problems. Thank you.
Thank you so much, Nathan, for this very rich and interesting presentation. Thank you so much. And now we are proud to welcome Lemken with Rick. another presentation, followed by probably, let's see, Eco-Robotics and Sebastian if he's available. We'll see.
Okay, hello. So I'm Rick Alves. I'm product manager at Lemken, working in the field of the mechanical weed control. So today I'm here for Lemken. Originally I'm from Stekete, Dutch brand. We've been working for mechanical weed control already for a lot of years. In 2018 we have been acquired by Lemken, and we'll talk some more words about it later. So, as Lemken, we have the goal to help farmers for the next generation. We want to supply all the tools a farmer needs to be able to work also in the future. And by that, I want to focus today on the mechanical weed control. How will that look for the future in the point of Lemken? So mechanical weed control, it's not only just a few machines, it's an entire cycle, which we want to also to show here. Lemken already had soil and tillage equipment for years, and with soil and tillage, it's also a kind of mechanical weed control. If you do a good plowing or a good seedbed preparation, you also kill a lot of weeds. A lot of people think weed control, it's only about hoeing, but it's about the entire cycle. And this cycle, we have some mechanical weed control. So we have the weed harrow, we have an easy weeder, and we also have the icy weeder. Today we also have the icy weeder here on the booth, and the icy weeder can work in between plants. It has knives which open and close, so we can work in between plants. With the easy weeder, we only have a side shift, and by that we can work between plant rows, but not inside a plant row. So the icy weeder. If we look to the icy weeder, here it's still in the Stekete color. We have knives which open and close, and we open and close them pneumatically. Underneath the hood we have cameras. We have multiple cameras, and with these cameras we detect crop plants. We detect each individual plant. And we use in vegetables, we use an RGB camera. So we detect plants based on plant color. We can do it on a green mode, we can detect green plants, but we can also detect based on a color mode. So for instance, not only green letters can be recognized, but also red letters. We have different working with, so we can have the machine in a rigid type, but also a foldable type. So we can go up to 6 meters in total. And the work speed is very limited, so you need to go wider, so you have enough capacity. And the main aim of this machine is to save a lot of manual labor. Oh, now it goes 2 times. Okay. So here you see the machine again. This is a configuration made for beds of salad. So in the wheel tracks we have standard hoeing elements, and on the bed we have the elements which open and close, so we can also work in between the plants. And this is how it looks like on a terminal. All the vision is made in-house at Stekete. And that's also the reason why Lemken acquired Stekete, because of the camera technology. The terminal is really easy to operate, it's very intuitive, and it's all in-house developed. Like I said, Lemken acquired us for the camera technology, and now all the machines, formerly Stekete, also are now in Lemken brand, and also the Lemken color available. And the Stekete brand has stopped. So now all machines, the icy weeder, but also the AC weeder, it's all in blue color only available. And they will be produced in a new production plant. We just have finished a new factory in Dinteloord, near the sugar beet factory in the Netherlands. We have a new plant where we will build all the mechanical weed control, and will be a crop care competence center. And we are also working on AI, so artificial intelligence. Like I said, with the machine for vegetables, we use a standard RGB camera, and we use the standard technologies to detect plants. But right now we also have for sugar beets an AI module. And with AI we can detect each single sugar beet plant. And the main reason why we developed AI for sugar beets is that a sugar beet is a seeded crop, and vegetables are often planted. In planted crops we have the advantage that we have a decent crop size and it's easier to recognize. As sugar beets, when we seed the sugar beets, we move all the soil, and therefore also all seeds start to germinate and to grow. And therefore in sugar beets it's really difficult to detect, and therefore we developed AI for sugar beets. This is how it will look like on terminal. And then about autonomy. So around us we see a lot of autonomous vehicles, but at Lemken and Stekete we have our vision about autonomy is that not the tractor is leading, but the implement should be the leading factor in the autonomous story. And that's also the reason why Lemken started combined powers. That is an autonomous vehicle, but this is our own vehicle. And because it's our own vehicle, we can use our implements to guide the vehicle and also to change speed, change working depth, to control everything. Until now we are really blocked by the tractor manufacturers that they won't give us access to all the electronics of the tractor. And that's the reason why Lemken, together with Krone, decided to make their own platform. So we have the machine controlling the tractor and not the other way around. And that's very important into our eyes. Then a little bit about process intelligence automation. We think that the machine should be the smart thing, and we only see a success for autonomous machines if we also have a self-controlling and self-setting machine. And that's also the reason why the current IC reader is not autonomous. So we have automated the process, but it's not autonomous because we don't have the control. We don't have someone checking what is happening, and therefore we still need a driver on the driver's seat to check, is the work going according to what we want. Otherwise, maybe a stick is in between the hoeing elements and you will cut out all plants. And of course, that's not what we want, and therefore we need the driver on the driving seat. Also an example what we also showed at the Agritechnica, that's tool control. So it's not only control of the work, but we also need to check, for instance, are all the blades still on our machine? So we can detect, for instance, on the Karat, if all the tools are still available and if none of them are broken. So, thank you for your attention. If you want to visit us, we are there. And we also have a second stand where we also have all other Lemken machines. Thank you.
Thank you so much, Rick. Thank you very much. And there will be another pitch tomorrow. And your booth is right here. Thank you so much. And now I would like to welcome Aaron for a presentation of Ilvo.
Yep, merci. Just check if it works.
There you go.
It works.
Yeah. It's our technician is perfect. Niels.
Just a little attention for the technician.
Exactly. Bravo, Niels.
I'm also a technician, that's why. Okay, hello everyone. I'm Aaron from research institution Ilvo, the Institute for Fisheries, Food and Plant Science. I'm a little bit different than all the other parties here. I'm not here to sell you something. I'm here to show you our innovation and the work we do in the Living Lab Agri-Food Technology. And here are already some of the things we do. So Living Lab is, I'll explain it furthermore in the presentation. But these are already some of the projects, some of the cases, the research topics we work on. Robotics, our electric tractor, as you see, our electric autonomous tractor. You see over there the middle robot you see here just behind the seats. Hyperspectral, drone imaging, other robotics. So we'll do an overview and especially how we work in our Living Lab agri-food technology. So ILVO is a research institution, part of the Flemish government, and here's a bit an overview of our site and a very big organigram of how we function or how we're divided as a sort, so technology, animal science, social science, and plant. And in those 4 categories, there's a whole lot of research groups who work on a whole lot of different things. It's not really interesting for you guys to oversee this, and also some living labs. And here you have our site. So the interesting thing about our research institution is that we're closely related with our other partners from the plant department for plant research, and we have around 250 hectares of research fields we can use for testing our robotics and testing our applications and inventions. Here you see one of our demonstrations we did, I think, this summer. Yeah, it was this summer with one of our robots. And that's a bit the way I want to present our Living Lab. And that's a bit the structure. So we analyze what is needed in what do farmers need, what is interesting to develop. We design, and then you see the 1, 2, and 3, and that's the interesting part. Is we go through this cycle a numerous amount of times. So we test, we do a demonstrations like you see here, and then we evaluate. We get feedback, and we integrate the stakeholders. We integrate farmers. Farmers from tree nurseries, if it's a tree nursery related project. We connect them in our workflow. They give us advice, or we form advice, and then we start again. We iterate on that design, and we go through that cycle a few times. We demonstrate, we evaluate with the stakeholders. We always get feedback from farmers, from manufacturers, from tractors or sprayers, as you see here. And that's a unique cycle we do in our Living Lab together with the stakeholders and together with the farmers. And that's one thing we really are proud of, and we really stand for, as we cooperate, co-create, as it's all these big words, co-create with farmers and the people who want to use such robot. A bit of the design, and my software colleague who will come tomorrow and do the same presentation will give you a broad view of his software overview and the whole of the robot. But it's a bit how we work, the design. And also what we can, something I can tell you about this design. So it's already an iteration of the first design. I think it will be in the next presentation. But this was also made together by Lambers Machinebouw. It's a Belgian mechanization company from Temse. So we do work with, as a Flemish research institution, we do work with local parties. And they are also integrated in the flow of the design and the improvements we do. Some of the pictures of our lab. So a bit the same with the tractor. So we got the tractor from Case New Holland without an internal combustion engine.
And then we put in all the necessary electronics, the drives, the motors, the batteries, all the steering, the white boxes. I can show you that after the presentation in more detail. And that's what that's something we do. It's one of our projects we present here, but that's something we do totally in-house. We get the frame from Case New Holland, and then we totally make it electric and autonomous, and that's the interesting thing about this. Some images of our workshop, how we added custom parts to an existing tractor where we didn't have the CAD model, so we use 3D scanning, we do water jets, our CNC equipment. Yep. Some prototype examples. It's always the same robot, but always doing different things. In the bottom left, you can see it measuring the density of the soil density. In the middle, you can see where it uses a weed burner, where it burns weeds on potato ridges, on the side, on the middle of potato ridges, to kill the weeds and to kill the weed seeds, as itself can also be killed by a small flame. And on the top right, there's another mechanical weeding application. And that's the thing we, with this robot specific, we look at is mostly mechanical weeding, as there is a lot to win in automating that step, especially for farmers that do that produce biological produce. On the top you see how we work if we use a task map. If we put a task map in the tractor, in the robot, we make images with a drone. The images and the positions are sent over 4G or 5G network. They're analyzed in the cloud via AI, and that task map can be sent to robot sprayer. That's something we also do with the sprayer. We fly over the fields. It's analyzed, and then we can spray with a 6-meter wide sprayer, totally autonomous, on a 25-meter nozzle width. I have no connection with, yep. And some, maybe a slide that would be relevant more early in the, in my little presentation. So here you can see already some of the iterations in this robot prototype. So we weren't able to lift big equipment, big implements with the robot in the first iteration. So we changed the build-up to be more higher, and now we're able to lift up more bigger implements. And that's the relevant thing here also with this robot. It's an implement carrier, so it can carry all implements that a regular farmer has for his tractors. Another robot. This is based on an existing tracked platform. And we added electromotors, batteries, steering, and then also the necessary GPSs. And then we added on the side a small spraying boom, 5 nozzles 10 centimeters apart. These are Dynajet nozzles, so PWM. So they can be switched off individually, and the volume can also be adjusted. And that's, I think, one of my last slides. So if you're interested or you want to know more about our electric autonomous tractor, just pass by with me and our beautiful blue New Holland tractor. I can tell you a lot about it, and these are some of the images in work. And to finish off, this is all within our living lab. We work together on the Agri-Food TEF project. It's a really big European project where in the living lab we work on the lower technology readiness levels, and in the Agri-Food TEF project we support AI and robotics companies to test and experiment with their technology, to give them advice, and really from a research and from a farmer side. So we all have a farmer's background, and we can evaluate technologies from AI companies and from robotics companies to show them the way to market what farmers really need. And if you want more info, you can come with me.
Thank you very much, Aaron, for
Okay.
the presentation. Thank
Please.
you. And
Okay.
of course, your booth is right here.
Yep. Thank you.
Here all day.
Thank you.
Last presentation will be from Sébastien Branche from Eco Robotics. Yes, he's arriving. Sébastien Branche.
I think English is better because...
Est-ce qu'on peut faire en français? En français, c'est bon? French? It's okay? French for all of you? I will go English and French. So, hello everybody, I'm Sébastien Branche, Sales Manager for France and Belgium at Eco Robotics. Eco Robotics is a Swiss company. It was founded in 2014 with the desire to bring robotics for sustainable agriculture. We started with 2 autonomous robots. The first one with 2 delta arms that moved and sprayed plant by plant. We already work with AI to detect every plant. It was an interesting technology, but it was not going fast enough. So in 2019, we decided to put that technology behind the tractor, the standard tractor, on the 6-meter machine. So now we have ARA. It's a sprayer of 6 meters with 156 nozzles. The nozzles are every 4 centimeters. It's just behind here. You can come to see the machine later. And we have 6 cameras under the machine. 3D camera that will detect the height of where we take the photos. And it also pilot the height of the boom to be always at 26 centimeters over the target. And so what machine is able to do is to spray plant by plant on a spot of 6 by 6 centimeters. So 6 by 6 is like mostly more or less like that. So we can detect the crop about 2 centimeters and the weeds even less than 1 millimeter. It's really precise. And the precision of the positioning is about 1 centimeter. So the spot on 6 by 6 we can control with many algorithm and software. We can guarantee that we locate it with 1 centimeter accuracy. So we did develop, I think you already talked about that this morning, but we use artificial intelligence to know every plant, the crop, and the weeds. And on top of that, we are able to detect the crop, the grass, and dicotyledons. And we can spray only the grass or only the dicots. And it's the list of the algorithm we already have. We have like 4 or 5 new algorithms every year. But with the all green mode, we already can work on all the crops. We can do fungicide on any crops. We already work on potatoes, for example. So when we detect the crop on the weeds, then we have to tell the system if we use, I didn't tell you yet, but the mixture is on the front of the tractor, and there's a permanent flow in the boom. It's a standard mixture, so it can be with selective herbicide. If it's selective herbicide, we tell the system that it can touch the crop. Even if it touches the crop, it won't damage it. If it touches the crops, it's just one leaf maybe. So we can already increase the quantity of chemical in the mixture, make a stronger mixture to be efficient at the first time. It's stronger on the weeds. With that mode, we already save around 80% chemical, 80% of herbicide. As we don't touch the crop, we can have a better yield because there's no phytotoxicity and a healthier crop and better efficiency. We have now more than 150 machines around Europe. We already work on more than 50,000 hectares. And the average saving is about 80%. And with a better efficiency. And we don't have many numbers about the yield because it's really hard on the whole crop cycle to measure the yield. But we see on the field that the crop is healthier. Otherwise, we can use non-selective herbicide. That mode was created to spray glyphosate on the crop. So then we create a safety zone around the crop. It's about 4 centimeters. It's here. And the system cannot spray inside the safety zone. So we can go on the crops and spray glyphosate with a good result. It's very efficient and cost efficient. It depends on the countries. For example, in France, it's not allowed to spray glyphosate in the crop, but in different countries in Europe, the regulation is different. So it works. Still, we have to be careful because the glyphosate can come through the roots, and you can find it in onions, for example. So it could be dangerous for the residue. Of course, we can spray also the crop. Fungicide, insecticide, fertilizer, plant by plant. For example, we did TPK on the sugar beet with 85% saving. Video to show you what it's done. So most of the machine work on grassland. We spray thistle and rumex on grassland. It's mainly in Switzerland. But in the other countries, we mainly work on the row crops. We can work on corn, like as here. So I tell you again, but here it's selective herbicide, so you can see sometimes it sprays on the corn. Can touch the corn, but it won't damage it. But we have, I would say, around 50, 60 machines working on onions. It's the crop where it's more complicated to remove the weeds with a standard sprayer. Even with mechanical weeding, there's some limits. There's a big demand on chicory because there's less and less chemical for chicory. And so we start on mainly on vegetable crops or specialty crops or seeds. But we can do corn, soybean, rapeseed. We have an algorithm for wheat, for the decot in wheat. We didn't try yet, but I think there's a big potential in here. And we are working to be able to detect even the grass on grass. So there's many things to do. It's the beginning of a new era for spraying. So can take your questions.
Are there any